Rocks. Now you have learned about the minerals. Minerals are the building blocks of the rocks. By definition, a rock is an aggregate of one or more minerals. That is, some of the rocks have formed by one mineral. These are called monomineralic rocks, but other rocks consist of several minerals. There are major rock forming minerals. In this table, you can see major rock forming mineral groups. For example, plagioclase, microcline, or orthoclase are the minerals belong to feldspar group. Quartz is very common mineral in many of the rock types. Calcite is a major mineral in carbonate rocks. Review this table carefully and think about what rocks that will be forming from these minerals. Oxygen and silicon are the two most common elements on the Earth crust. More than 90% on the crust is composed of silicate minerals. Most abundant silicates are the feldspars, such as plagioclase, alkali feldspars. Other common silicate minerals are quartz, like 12%, and pyroxenes, 11%, amphiboles, 5%, micas, 5%, and clay minerals, another 5%. The rest of the silicate family comprises 3% of the crust. Only 8% of the crust is composed of non-silicates, such as carbonates, oxides, sulfides, sulfates, native elements, etc. Rocks can be classified into three major categories: igneous rocks, sedimentary rocks, metamorphic rocks. Rock cycle is to show the relationships between these rock types and the sediments. Sedimentary or metamorphic rocks become igneous rocks by the process of magma cooling or magma solidification. Igneous or metamorphic rocks can become sedimentary rocks by the processes of weathering, erosion, sedimentation, and lithification. Weathering forms sediments from any of the three rock types. These sediments transported, deposited, cemented, lithified, and form sedimentary rocks. Sedimentary or igneous rocks can become metamorphic rocks by the process of metamorphism. Heat and pressure influence the process of metamorphism. Again, we'll discuss about the rock cycle, and you can see example for each different rock type. Granites an igneous rock. Sandstone is a sedimentary rock. Gneiss is a metamorphic rock. They form at different conditions or different environments. Let's look at igneous rocks. Crystallization of melted rocks form igneous rocks. Based on cooling environment, some igneous rocks have fine grains and some igneous rocks are coarse grained. If the cooling rate of magma is high, there is no enough time to form large crystals. You will expect fine grained igneous rocks such as basalt in this picture. If the cooling rate of magma is low, there is enough time to form large crystals. Therefore, you will expect coarse grained igneous rocks such as granite in this picture. Igneous refers to fire in Latin. Igneous rocks form by crystallization from a magma originating from the high temperature lower crust or upper mantle. As I mentioned before, the rate of magma cooling defines the type of igneous rock that results: fine grains, extrusive igneous rocks, or coarse grain, intrusive igneous rocks. This is the classification of igneous rocks based on the texture and chemical composition. Take a copy of this chart and keep in front of your study table and look at it. What is a texture? Texture is the size, shape, and arrangement of the crystals. Here you can see examples for fine grain or extrusive igneous rocks such as rhyolite, andesite, basalt. Also, examples for coarse-grained intrusive igneous rocks such as granite, diorite, gabbro. Based on chemistry, there are four major igneous rock types: felsic, intermediate, mafic, ultramafic. Pay attention to the changes in chemistry in this chart. Calcium, magnesium, and iron percentages are increasing from felsic to mafic, from left to right in your chart. Also, you can see higher percentages of potassium, sodium, and aluminum in felsic igneous rocks. Chemically, rhyolite and granite are similar. They both felsic igneous rocks, but they are different in their texture. Andesite and diorite, they are compositionally similar as well, but they are different texturally. I hope you understand the igneous rock classification based upon chemical composition versus texture. These are examples for coarse-grained versus fine-grained igneous rocks and mafic versus felsic rocks. Felsic means feldspar and quartz, mainly silicon and oxygen. White color minerals and lighter color rocks. Mafic means magnesium and iron, darker color minerals and darker color rocks. Minerals are forming in the magma chamber during igneous rock formation. Bowen's reaction series explained the formation of mineral at specific temperatures. In other words, some minerals form at higher temperatures and some minerals form at lower temperatures from different types of magma. Bowen's is the scientist who explained this Bowen's reaction series for first time. This aligns all of the different minerals according to their cooling temperatures. For example, olivine is the first mineral to form in a magma chamber. Quartz is the last mineral to form in a magma chamber, but quartz is the most stable mineral on Earth's crust. Sometimes you can see the rims of quartz forming around potassium feldspar. You can see potassium feldspar in the center, and surrounding you can see quartz formation. Why this is happening? So feldspar is forming before quartz. What's end up happening, surrounding the feldspar grain, the fluid is going to react and forming new minerals. So this is why you're going to see quartz around feldspar grains. Why are there so many kinds of igneous rocks? Well, as we explained before, based on magma composition and cooling environments, we will have different igneous rocks. Let's talk about sedimentary rocks now. Weathering process forms sediments. These sediments eroded and they get transported and deposited to form sedimentary rocks. This diagram shows how granite get weathered with time and forming sediments or the secondary products. Granite is an igneous rock. Granite or granite contains minerals of plagioclase, quartz, biotite, amphibole, orthoclase. Likewise, orthoclase and plagioclase, these are mainly silicate minerals, lighter in color. They are going to form clay minerals. The weathering of orthoclase or plagioclase, especially the chemical weathering of feldspar minerals, will form kaolinite or clay minerals. Ferromagnesium minerals such as amphibole, biotite will become iron oxides because they do have a lot of iron and magnesium in those minerals. Ferromagnesium means iron and magnesium. So you're going to see a lot of iron oxides. This is why you see some sedimentary rocks having layers of reddish brown color. Those are like hematitic layers or the iron oxide layers. And this is the same reason you see reddish color soil in southern states, like in Mississippi, it's a reddish color soil. Same reason. What about quartz? Quartz still survives as it is the most stable mineral on Earth's crust. So these are different sedimentary environments where you can expect to see sedimentary rocks. Glacial, fluvial, beach environment, deltaic environment, and deep marine environment, aeolian, it's like desert, alluvial fans where rivers ended up into a flat or the meadowland or the lowlands, and lagoonal environments. So these are sedimentary environments. There are major different types of sedimentary rocks or the sediments. The clastic or detrital sediments, that means physically they transported rock fragments. They're produced from weathering of pre-existing rocks, typically silicate minerals or rock fragments such as quartz, feldspar, pyroxene, clays, rock fragments. So you are going to form sandstones, shales, conglomerate, breccia, like detrital sedimentary rocks. They're coming from pieces of rock or mineral fragments. They come together and they're cemented and lithified and forming detrital or clastic sedimentary rocks. Chemical or biochemical sediments are forming chemical or biochemical sedimentary rocks. Direct chemical deposition, either by chemical reaction or biotic production, typically in marine settings like oceans, you can see limestones or soils. So when you come to the chemical or biochemical sedimentary rocks, one thing to keep in mind is these are forming from the solution. For example, if you think about limestones, they're precipitating calcium carbonates and all of these carbonate minerals from solution originally. Source for the clastic sediments is physical and chemical weathering in high areas produces this raw material. For example, if you think about the higher the areas where you're going to start a mountain, that is like the good place to do a lot of weathering, lot of abrasion, making a lot of rock fragments because it's high energy environment, lot of erosion, lot of weathering. And sediments are transported via water, wind, ice. At the end of a river, like old or later stage of a river, it's low energy and cannot even move fast, very slow sediment movement, like in Mississippi Delta. This is a good place for sediment deposition. So low energy versus high energy. Where you have high energy, you're going to start erosion. Where you have low energy, you're going to do deposition. Conglomerate. Conglomerate is an example for a detrital sedimentary rock. Gravels are well rounded in a conglomerate. This tells that these gravels were transporting long distances. Gravels in a conglomerate are very well polished and well rounded by the process of abrasion. Sand-sized particles. They are forming sandstones. You can see the reddish brown layers in this sandstone. Like we explained before, these are oxidized iron magnesium bearing minerals. They are now oxides, like rust, iron oxides. Mud-sized particles are forming mudstones. All of these are detrital sedimentary rocks. Carbonate environments. Chemical or biochemical sedimentary rocks are forming from solution, as I mentioned before. Shelf and reef deposits are examples for chemical sedimentary rocks. Also, stalactites, stalagmite in limestone caves are chemical sedimentary rocks. Mammoth Cave or Ruby Falls will give you best examples for chemical sedimentary rocks, like a lot of carbonates. Evaporites. Evaporites are another chemical sedimentary rock forming from the solution. Sodium potassium chloride in oceans may become oversaturated as water evaporates from restricted basins. That results salt deposits or sulfates. For example, halite and gypsums are very common major minerals that you can find in evaporite deposits. So this is also showing the Mediterranean and chemical sediments. The chemical sedimentary rocks are forming in these areas, and you can see gypsum and halite are major minerals. Last rock type is metamorphic rocks. Temperature, pressure, and presence of fluids control the metamorphism or the formation of metamorphic rocks. Usually, metamorphic rocks are layered or foliated, but there are non-foliated metamorphic rocks as well. This is a metamorphic rock. This is actually a typical metamorphic rock where you can see the beautiful layering. These are called foliations. Regional metamorphism. When we talk about metamorphism, there are different types of metamorphism based on the temperature, pressure, and the fluid conditions. Regional metamorphism occurs due to high pressure and high temperature. This is very common type of metamorphism during mountain formation processes, where you're going to have a lot of pressure and temperature involved. Skarns are examples for contact metamorphism. In this case, igneous intrusion into carbonate rocks. The carbonate rocks get metamorphosed due to the temperature of the igneous intrusion. So you're going to see a lot of gem quality deposit after this intrusion of igneous melts to this carbonate environment. Impact metamorphism. This occurs when high-speed projectiles called meteorites strike on Earth's surface. These products are called impactites. You can see a sudden change. You can see the circular nature of the impact. You can see the shutter cones in these areas. The Sudbury meteoritic impact is one of the best examples in Canada. You can really go there and see these metamorphosed rocks after the meteoric impact. That's Sudbury meteoritic impact. So metamorphism progress from low grade to high grade. That means low pressure temperature conditions to high pressure high temperature conditions. There are certain minerals that you can expect to see at different pressure temperature conditions of the metamorphic rocks. High grade metamorphic rocks will have sillimanite. It's an anhydrous mineral. There's no water or hydroxyl component or H2O component within the chemical formula of that mineral, because there's no way to survive hydrous conditions at these high pressure and temperature conditions. If you look at a low grade metamorphic rocks, you will have lots of chloride, which is an anhydrous mineral. So likewise, by looking at this chart, you can see low grade to high grade, it's changing the composition of the metamorphic rocks. When you go to the high grade conditions, you're not going to see lots and lots of hydrous minerals. But at low grade, you're going to see a lot of chloride, muscovite, biotite. Those are hydrous minerals. But when you reach to high grade conditions, you're going to expect to see a lot of kyanite, sillimanite, lots and lots of quartz and feldspar. But you can see in this chart, eventually you keep increasing temperature, keep going, and at some point you're going to reach to the melting point of these minerals, and this is where rock cycle is going to complete. So these rocks become the melt of it and starting this magma and then starting to form igneous rocks. So likewise, this is rock cycle is continuing. Foliation in metamorphic rocks. Now when you think about sedimentary rocks, you had a lot of layers or beds of sedimentary rocks. But when we come to the metamorphic rocks, we don't call them beds or stratigraphy or strata. We call them foliations. The planar minerals align due to their growth under differential pressure, one direction of pressure greater than others. So this will gives the ability to form the foliation. Sometimes if you do not have this mineral alignment, sometimes it's a structural alignment like platy appearance of the metamorphic rocks will give the foliation as well. Platy minerals defining foliation are typically form the mica family. The sheet silicates, the mica minerals, layered kind of mineral. So you can see, as you can see in this picture, the bottom to the microscopic views, you can see these feldspar, quartz and mica, the green color, the laths of minerals. Or you can see this alignment of mineral grains according to these pressure conditions. So this is what we define as the foliation. There are foliated metamorphic rocks: the slate, phyllite, schist and gneiss. You don't see gneiss here, but you will see that in the next slide. So slate, phyllite, schist and gneiss, they all are foliated. So the slate is very similar to shale in color and the texture, but it's stronger than shale. So there's no any minerals that you can identify in slate. It's a very primitive, very low grade stage of metamorphism. When you increase the metamorphic grade, you reach to the phyllite, you can see a lot of micaceous, or the sheen of this muscovite mineral, or the sheen of these micaceous minerals. And then you're going to form schist, that is intermediate to high grade metamorphism. You can see beautiful red color garnets and shiny flaky biotites that defines the foliation. In this picture you can see where you can expect to see these different types of metamorphic rocks at mountain building process. So this is an example. This is continental convergent boundary, and for example Himalayas, the formation of Himalayas. So you can expect to see lots and lots of metamorphic rocks over there. And you can see slate is more superficial or subsurface, very shallow depth. Phyllite and schist and gneiss is at very deep. So the gneisses are most, you can see the most defined foliation in gneisses. At sufficiently high temperature and pressure, the rocks begin to melt, eventually to form granite. So this is where the metamorphic rocks become igneous rocks. Rock cycle continues. Marble quartzite, hornfels, these are common non-foliated metamorphic rocks. So the non-foliated metamorphic rocks are very common during contact metamorphism. With that, you can review the chapter 3 from the textbook and take the quiz. Quiz has 2 attempts, I should remind you. You will be able to see wrong questions, but you won't be able to see the correct answers until the deadline reached.